Yes, good morning, everybody. It's almost time, so I think we should begin. Firstly, I'm Manu Gupta. I'm a senior manager working with Acuiti Labs, handling our marketing operations and all our marketing activities that is happening here at Acuiti Labs. That's just a quick one about me. We are doing quite a lot of interesting stuff in the multimedia side, streaming, video codec. So we'll be covering that today in our today's webinar. As we go about saying low latency video streaming, that's something everybody is looking after, trying to work and trying to understand. So we will uncover that today. Talking about Acuiti Labs, we are a very fresh, a new startup, started a few years back, and we've been doing quite a lot of work in multimedia in codec, as I said, and we aim to delight our customer, help others delight their customers as well when it comes to doing great work in video streaming. With this, I would like to introduce our multimedia expert who handles a team of about 25 people, 25 video engineers, multimedia engineers over here. Rakesh Sharma. Rakesh?
Yeah, thank you, Manu. So, hi everyone. This is Rakesh Sharma, and here I am to talk about low latency video streaming. As the topic said, I have been working in this industry from more than 15 years. I have been associated with companies like Nvidia and Motorola in the past. I have seen multimedia industry evolving from the years with respect to technology and customer experience. I had been fortunate to work on several interested projects in the past, and recently my complete focus is toward streaming industry. At Acuity Labs, we have a common vision to support and provide best multimedia practices. So that's all from about me.
All right, great. So that's a quick one and quite interesting one. Thanks, Rakesh. Thank you for that. I think we've covered the introductions. So we will move to the next session. That's the most interesting one. So we'll be covering some interesting questions in the session, about 5 questions. So let's start. Everyone here is quite familiar with low latency. They know something or the other about low latency streaming services, but it would be great if if you could elaborate on this topic and talk a little bit more, get everybody familiar.
Okay, thank you, Manu. So,
Rakesh, I guess you're not audible. Just wanted to check.
oh, is it fine
Yeah,
now?
yeah, better, great.
Okay. So, let me start with the basic of low latency. So, in layman terms, if I want to talk about what is low latency, it's nothing but a lag between actual event and the time where it is viewed by the user, by the viewer. Okay. So, in this diagram, you can clearly see there's a broadcaster and viewer. So, broadcaster is broadcasting the event at T0 time, where the viewer is able to view at T0 plus 20 second. So this 20-second is actually a latency. So as so you can also define it as the time between cause and the effect of some physical change. Okay. So let me more elaborate the latency spectrum. Um, there's a very noise, a big noise coming out from there. Manu, can you mute yourself?
Yeah, 1 second. Sorry about that.
So let me explain you about the streaming latency spectrum. So as you can see here, there are multiple bands of latency. You can say high latency, standard latency, low latency, ultra low latency. In sub-second, that comes around a real-time latency. So the protocols that comes under the high latency are HLS and Dash protocol, which which gives you more than 30 seconds of the latency. And so you can also improve this part by uh, reducing the segment size and increasing the infrastructure. Your high latency will move into a standard latency where you will get a good latency improvement. And when I come into a low latency part, there's a CMAP protocol which takes effect to achieve the low latency. So in HLS and Dash, if I want to achieve a low latency, I need to use some of the protocol and standards like chunk encoding CMAP, which I'm gonna explain you in the upcoming slides. And the most widely used for real time and ultra low latency is WebRTC, which is a real time communication protocol. Let me also explain about the parameters which affect the network latency, the actual video latency, streaming latency. So these are some of the causes of latency. So you can see video encoding pipeline duration, ingesting and packaging operations. All these are the causes. So video encoding pipeline duration. So certain encoders introduce additional latency as they can only output a chunk of media once it has been completely ingested. So you need to choose a proper encoder which can improve the latency. Uploading the package in the network and all those stuff is basically depend on the network connectivity, whether it's a wireless connection, whether it's a leased line, fiber optics, all those network connection does matter. The content delivery network, CDN propagation is also very uh, it also added the latency in the pipeline. In order to deliver content at a bigger scale, most media pipelines leverage the CDN as it result into a network propagation of the content, which adds the latency into it. The most important part is the segment length. So by managing a proper segment length, we can reduce the latency. And the last but not the least, the player policies. So player policies are also very important thing. So one of the example like buffering. So if my player plays a video after 5 seconds, it buffers 5 second video. So even though I am getting a video feed from a streaming server in a second, so my latency will be 5 second plus a second, that is 6 second. So managing those buffering part and resilience part of the player is also very important. I think that covers the basic of the latency. Does that, Manu? I think you're
Yes, it does. Yeah. So you asked me to be on mute. So sorry for that. Yeah, it does. It does definitely. So you have covered, what exactly is latency and different type of latencies and the protocols, and also talked about the causes of latency. So that's quite useful. Great. So the next thing that we would like to cover would be the applications or areas where we see usage of low latency. So if you can cover that, you can talk about that. That would be great. Yeah.
okay. So thanks for that question. It's a very good question, Manu. Usage is definitely one of the area where people don't have a clear understanding where exactly it's a game changer. So let me talk about few areas where low latency is actually beneficial and very important nowadays. There are multiple areas, but let me focus on some of the areas. The first one is very much useful in nowadays in the daily life. So that's a video chat and conferencing. So in video conferencing or chat application, latency will cause receiver to get delayed information without a clue about actual gaps. So this can totally disturb user experience. So you can take an example where a live journalist is interviewed by news anchor at distinct location. It takes several seconds before the correspondent can respond to anchor's question. So this will negatively impact user experience. Uh, the another area which I want to uh, list down here and explain is the live sports and esports applications. So uh, the field where we see a latency is very important is live sports event, where audience is interacting with the live event. So in live sports event, sports have evolved a lot from how they were played and viewed traditionally many years back. The action reaction time to the audience is very critical, and that's where the low latency play a crucial role. So people are nowadays using gaming platform like Twitch, where everybody do contributions. So on those platform, the live interaction happens, and there comes a need of low latency. The last example which I want to mention is the second screen experience. So when you have a second screen watching along with your television with regular broadcast, so latency preferably matched at least the latency of the broadcast itself. So if the broadcaster having 6-second latency, you have to match that latency. Otherwise, the user experience will be very bad. I would like to cite a very interesting one of the project which we did recently for a Canada-based streaming client. So they have an application where they broadcast a live event through PIP. Then the audience interact with the live application. Uh, this is exactly like an application where some presenter is presenting something, and the live audience can join and ask the question. The question asked is uh, will go to the presenter's screen with with the help of PIP, and there uh, it mixes audio and video, and we can see the complete thing working together. So we have helped those that client to achieve a low latency while streaming their video question with the live event, which in turn become a very good customer experience because the live audience ask a question, and the presenter should be able to answer that in a real time manner. So that's one of the application where it's very important for low latency is very much important. So I think that answers your question, Manu.
Yeah, it does. It does. So definitely, when we are chatting in personal space or having, live conferences in our offices, definitely any lag in video streaming is something not acceptable, something not liked. So definitely, I think, keeping our latencies low with these protocols can really help. All right. So that's great. Thank you for that, Rakesh. Yeah. So I'm very keen to understand what kind of technologies, or what are the latest technologies which are used to keep the latencies low or ultra low, as you said, and which ones are the most preferred and reliable ones, technology protocols, if you can talk about that.
Definitely, Manu. I'll talk about it. That's a very good question. I'll answer that in three part. So first, I'll explain about the CMAP, which is a very important part of it to achieve a low latency. CMAP is nothing but a common media application format. So let me first explain how the latency propagate through CDN. So CDNs receiving the incoming segment typically wait to receive the last byte before forwarding on the first byte, and player wait to receive the last byte from the CDN. before beginning the to decode the first byte. So this pattern of repeated accumulation result into the overall latency loss. That is an integral multiple of the segment duration. So if the CDN is having 6 second segment, so it will completely send it. Then only player once the player completely receive this segment, then only it will start decoding the segment. So that is the latency which is getting added. So that is overcome through the CMAP protocol. So CMAP is nothing but a common media application format, is one of the most widely used format along with the chunk encoding for low latency. Uh, I can explain you here with the help of this diagram. It enables the delivery network to be more efficient in terms of the cache hit ratio. Chunk encoding and transferring smaller amount of chunk instead of waiting for bulk network packets can be dramatically reduce latencies. So let me put it in a way. So CMAP comes with a low latency mode. This low latency mode allows you to split up an individual segment into smaller chunks, as you can see in the diagram.
Yeah.
So one could ask here, why would I need to split a fragment and not just make segments smaller? So the answer for that question is CMAP requires a keyframe at the start of every segment. This is not the case for a chunk. So a keyframe tends to be significantly larger than non-keyframes. A reduction in segment size would result in increasing the bandwidth. If you increase the keyframe, your bandwidth will be increased. So that's why we cannot reduce the segment size. So there it comes chunk encoding part. So as the diagram clearly say, you have the move item and mdat item. So in normal CMAP, you have to wait till the segment completely received by the receiver, then only it can play. But in chunk CMAP, you can get every move and mdat is individually playable. So once you get first move and mdat packet in chunk, you can start playback. So that's the beauty of this protocol. So let me now explain your second question, protocol choices. So which one is more reliable and which one is more preferred one? So it completely depend on the use cases. So if I have a small video chat kind of application, then I would go for the WebRTC, where peer-to-peer communication is more. The protocol is based on peer-to-peer communication, and the scale level of video chat is not a bigger level. But when there comes a scaling part, then the most scalable systems are HLS and MPEG Dash. MPEG Dash is actually an open source protocol, so which is most widely used. And if I want to develop a small scale applications or medium scale application, I can also go for RTMP and RTSP. So if I use RTMP and RTSP, so without doing this CMAP and all those stuff, I can still achieve the low latency part. So it's completely depend on the kind of use case that we have. So
Yeah.
does that answer your question, Manu?
Yeah, yeah, it does. It does. So definitely, even I feel that CMAF is a quite powerful protocol and can really help in situations and use cases. And protocol choice again is again a very trivial important part. So depending upon what the client or what the prospect is trying to achieve, they can make protocol choices. All right, great. So thank you
क्या है
for
ये क्यों है ये what is going on here
leading us. So we have somebody talking in. Wait 1 second. So I request all the all the guests to be on mute for a while we're having the conversations, and then we can take questions in the end. Thank you all. All right. So with that, we come to our fourth question. So definitely, Rakesh, from your knowledge, it seems you've done quite a lot of work in this area. So why don't you talk about what technologies you have worked with your team at Acuiti Labs and otherwise as well? What kind of projects you've done and how you have been able to delight your customer when it comes to streaming services or multimedia projects?
Okay. Um, Thank you, Manu, for asking that question. Let me also explain first some of the causes and how we can reduce this latency part, and then I'll answer your question. So I can. This is the smaller subset of how I can achieve a low latency part. So these are the areas where I need the improvement: encoding and packaging, first mile upload, CDN propagation, player buffering, and chunk CMAP, which I talk about. So I'm just listing them. So by doing the work optimization in those fields, we can achieve a low latency. Let me go to your question then. The
Yeah.
expertise and the work we have done in the this fields. So we are being into a multimedia field from quite a long time and doing a lot of work in streaming in other part. So we have done lot of work. But if I talk about specifically about the low latency part, I can give you a couple of examples where we have been achieved low latency on different clients applications. So I'll give you two couple of example. The first one is the VMS. So VMS is nothing but a video management system. Is also known as video management server. Is a component of security camera system that is responsible for collecting videos from cameras and other sources. Record, store the video to the storage device, and then provide the interface to manage those. So after doing a lot of study and analysis, we have chosen GStreamer based multimedia framework to implement the VMS. All the connected cameras are first scanned and added using ONVIF protocol. So let me explain what is ONVIF. ONVIF is nothing but it's a standard for how IP product within video surveillance and other physical security areas can communicate with each other. That's the standard. So using ONVIF, we can search the network camera and add them directly. Then we have designed a front end video wall where all of the cameras listed, and by clicking on view, you can see the live thumbnail from the cameras. The start stop camera feed options were present there. The use case was completely for the client where they should be able to specify how much data needs to store in chunk of files. So you can actually specify the length of the file or size of the file. So each chunk, once the size is once we the limit of that much size is achieved, we store that into file, and integrity is checked through the md5 sum. So here we used a RTSP based protocol and optimized the player to reduce the latency and keep it well within the 3 second time duration. So client was very happy with that. The another example which I want to share with you is RTMP support. So this is a project where everybody knows that the Flash support is going to be end soon. So RTMP is one of the major protocol which is used for a low latency, and it's a stateful protocol, and we have worked for a client to develop a HTML5 based JavaScript based player and added the RTMP support. We have been working on this part, and we are also working on the low latency support on RTMP side as well. So those are some examples that I could give you. If the time permits, I have a lot of examples, but I think we need to be in time. So I want to move for the next question.
Yeah. So that's quite an insight into those two things that you talked about, RTMP and the PMS as well. So great. Yes, I've heard about it. Those projects going on internally and people working on it. So that's quite great. All right. So finally, finally we come to the most important question of today. Um, how do you think multimedia companies can benefit from low latency video streaming, or how do you think it can boost their customer experience? Again, it basically talks about, or sorry, I'm basically asking about customer delight, boosting customer experiences, making them more interested, keeping them hooked. So how do you think low latency will play a key role there?
Thank you, Manu. Thank you very much for asking that question. So, customer experience or boosting customer experience is one of the most important aspect for any successful business today. So, in order to enhance customer experience, we need to follow basically three steps, which I'll talk about now. So, let me list out the three steps. First is the selection of protocol. The second is the implementation, and the third one is the result. So, let me go one by one. So, protocol selection is the most important aspect where you will decide the customer experience based on the use case. So, deep understanding of protocols and streaming technology are the key points where you will provide a clear picture of your choice that you have. Video streaming intend transmitting data online while enabling user to process it without completing the complete process of transmission. So it's like the server will stream the data, bit of data, and without completely getting that data, I can play from the viewer's end. So that's the beauty of streaming.
Mm-hmm.
So therefore, choosing a right streaming protocol that will perfectly suit the type of media you are going to use is very much important. Most of all video streaming protocols are transport based protocol, and they uses TCP and UDP for the communication. So there are different streaming protocol. Let me talk about that. So basically, I can categorize it into two part. One is HTTP based protocol, and another one is non HTTP based protocol. So I'll explain you some of the HTTP based protocol, HLS, HDS, and MPEG dash and WebRTC. Then non HTTP based protocols are like RTSP, RTMP protocols. So let me go through them one by one. So first one is the HLS, which is developed by Apple and Apple for iDevices, and it's widely used now. So what how it works is it divides a stream into range of file download and group them into a smaller chunks. So HLS is basically known for adaptive bitrate streaming, where it enable players to examine client bandwidth and stream video in an appropriate quality. So in order to provide this, it encodes media files in various quality level along with the index file of the locations. So that's how it managed at the server end. The next protocol which I want to talk about is HDS. So HTTP dynamic streaming, which is developed by Adobe. So as it's developed by Adobe, it's well protected security wise. So it provides on demand and live video streaming. HDS actually analyzes client bandwidth and delivers appropriate quality of video stream based on the internet connection. The next one I want to talk about is MPEG dash, which is the most widely used protocol nowadays because it's an open standard protocol, open source protocol. It's MPEG dash basically a codec agnostic protocol where in HLS you have a transport stream. You can only choose transport stream where HDS supports the MPEG stream. So in MPEG dash you can use any of the codec. It's suitable for any of the codec because it's a codec agnostic. Then I can go. I'll explain the WebRTC now. So, as the name suggests, WebRTC is mostly focused for real-time transfer. It's a peer-to-peer protocol. The only disadvantage which I see is most CDN doesn't support WebRTC yet, and the scalability is the biggest problem in WebRTC. There are some options, but they are not good enough as of now. So that's about the HTTP based. If I talk about non-HTTP based, there's RTMP and RTSP. So RTSP is actually a protocol which establish and monitor media session between server and client. So you can switch from TCP to UDP at any point of time. You can start watching your media file before it gets downloaded completely, and it's a stateful protocol. If I compare with the HTTP, which are stateless protocols. So let me go to the implementation part. So implementation is the actual part where the chosen protocol needs to be implemented for specific use cases. So you have already decided in this level that which protocol you want to use, and now you have to do a lot of different kind of optimization to achieve a low latency and better than low latency. So one of the best choice is CMAP, with chunk encoding must be used to achieve the low latency at encoder level, and the same you have to use at the player level. Player should also be optimized for chunk CMAP. Player buffering should be taken care properly. So in player buffering, if you have 5-second buffer as previously explained, then you have a T0 plus 5 second is always 5 second is always your latency at minimum. So you need to handle that for live case properly. So complete pipeline needs to be optimized at each and every stage to achieve a low latency. And the last part is the result. So if you have selected a right protocol and implemented in the right way, you will definitely get the good result, the desired result which you want to achieve. I would personally suggest adopting agile methodology for working to gain a good result, because you can do testing and development side by side. So it always provide a good result. So yeah, I think that's all about the selection criteria. Does that answer your question, Manu?
Yes, Rakesh. So that quite answers my question. So I understand that selecting the right protocol as per the use case, selecting the right environment, and then putting in all the right assets together will definitely get the results. Whoever it is, whatever it is, someone aiming for. In this case, keeping the latency as low as possible. So yeah, so that's quite insightful. So I think we've covered the question as we had planned. Now we are open to questions. If anybody's got any question, we can take a couple of questions before we end the session.
Yeah, so Mr. Rakesh, thanks for for the information you gave us on this topic. That was really good. Appreciate it. I have one question regarding your project. What you discussed in between regarding your Canada-based project. You said so. What could you please help me with the details? What you did exactly in that?
Thank you, Gaurav, for the question. So the project was for the live event where the presenter will be presenting a specific topic, and there are audience joined online. They can record their question, and the question will be played with the on the presenter's window. There, the presenter will answer all of the questions, whatever asked from the audience. So, in the live audience case, as I previously explained, the low latency plays a very important role. Okay, so we have done a lot of work in that project. So design, recording a question, all those other parts we have done it. There was some issues like PIP issue when you have recorded a question and that question gets into the presenter's window. The audio were getting lost and the PIP was also not coming. So we have resolved those problem from our end, and we have also optimized and made it in a almost low latency, and it to be in a lower side. uh, so how do we achieve that is like some of the things is like when you record a question, you actually do record a question, then transcode it in a specific format, then send it to the Amazon S3. From there it's picked up by the presenter, and the presenter will through PIP render on the screen. So so we have optimized this whole cycle by not to transcoding the um, uh, question, and uh, by uh, choosing a right protocol at the time of recording question itself. So these kind of work we have done for the client, a Canada based client. I hope this answers your question, Gaurav.
Yeah, yeah, sure.
All right. So thank you, Rakesh. Gaurav seems to be fine. Anyone else having any other question for Rakesh today?
Yeah, actually, one more doubt that I have, I came across in between. So, see, there are a lot of approaches from for the latency streaming nowadays, like sub latencies and ultra latencies. So, how you can how it is important to use a low latency, and what is the importance of low latency in as compared to this upcoming more superior options?
That's a very good question, Gaurav. So basically, it completely depends on the use cases. As I previously explained, if you consider the scaling part, you don't have a much options. So let me first explain you the WebRTC thing. So as I previously explained, WebRTC is a peer-to-peer protocol, and there's a restriction in the scalability. So if you want to use WebRTC, your product will not be as scalable, and there's a lot of CDN doesn't support WebRTC yet, so that is also one biggest restriction. So WebRTC doesn't suit you for a good scalable product. Okay, then the other protocol like RTMP and RTSP, to build a robust and scalable version of your product, RTMP and RTSP should be implemented in a right manner, and the development effort is a huge effort, and then also you won't be able to go to a real time and ultra low latency. You can, you might achieve by doing a lot of optimization, you can go to till ultra low latency, but the development effort is huge for those, because they are a stateful protocols, and you need to maintain all this state, and the chances of error handling and all those stuff should be taken care properly. Whereas if you go to a HTTP based protocol, it's a well stable protocols, and for the scalability thing, you can scale them as much as possible. So from the standard latency, we need to come down to a low latency, which is a huge number. The only reason we go for this is broadcasting thing happen in a scale, so where you have more than 1,000 viewers or something like that. In those application, you should use a very stable protocols and stateless protocol, where like HDS, HLS, MPEG dash, all the stateless protocols, HTTP based. And to come to reduce the latency, then you have to use all those optimization which I talk about. One of the best standard is CMAP, chunk encoding. Through that you can achieve almost low latency, or in future you might achieve the ultra low latency for those protocol. If you want to develop a small chat application, then WebRTC is most suitable. So it completely based on the use case what you want to develop. Does that answer your question, Gaurav?
Yeah, yeah, sure. That's it. That I'm done. I'm fine. I'm fine.
All right. So before we close, any other question coming up from the guests? Anyone? Right. So I think that's it. That's it. Rakesh, you've explained quite a lot in detail about all the protocols. So, presenting all the use cases, scenarios, and things. So quite interesting there. As
Thank
an
you very much, Manu.
Yeah, you're welcome. As an organization, Acuiti's vision is to continuously invest into new fields and streams of multimedia technologies, do some good, great work, keep our customer experience high, and keep delighting our customers. So, on that note, I would like to thank everybody, thank everyone who joined us today for this webinar. Thank you for your time. I hope you had a good time here today with us. Thank you, guys.
Thank you, everyone.